Let's start with our session today.
Sure.
Okay, so today we will be taking a deep dive into the Node.js event loop. Okay, understanding the Node.js event loop. So basically, do you guys have any idea what is the event loop? So basically, event loop is there in browser as well or JavaScript. So do you have any idea about it?
It is used in JavaScript,
Correct.
where like it checks for if the call stack is empty or not, and if it is there, then it takes the method available in callback queue and puts in the.
Yeah, correct. So similar thing. Okay. So currently on the screen, this is a browser JavaScript browser event loop. Okay. So not just there are few more components. So there is heap memory. Then we have stack memory. Correct. On for browser, we have a callback queue. Okay. So what does happen whenever interpreter reads the program or the code? Okay, so let us try to understand it using an example. Okay, so what does happen when our interpreter tries to read a script? So what it will store the it will store all the synchronous calls in stack memory. So like console.log is a stack memory, bar function and foo function. Okay, so what it does, all the methods and function calls will go into the stack memory. Okay, so now what will happen? Stack is first last in first out, right? LIFO. Or first in, no, not first in first out, last in first out. Okay, so now what does browser do? Browser will pop the first element, right? Okay, so what is the first element? It is console.log. Okay, since it is a synchronous one, it will execute as it is. Okay, now next is bar. Okay, in bar we have some asynchronous call. Okay, let's say an Ajax request or a timer function. Okay, so uh, so basically, as soon as program our script is able to identify that, okay, so basically our program runs in a asynchronous manner, right? In JavaScript.
Synchronous. Yes.
So basically, if there is some asynchronous script, JavaScript will run it, then it will go ahead. Okay, if next line is asynchronous, it will give it a call. It will not wait for response, it will go ahead. Okay, this is the asynchronous behavior, right? Okay, so in this case, JavaScript identified that, okay, this bar is a asynchronous thing. Okay, so what it will do, it will add that method into callback queue. It says, okay, you are asynchronous, you are going to take time. Okay, some callback will return some value in your future. So what it does, uh, it keeps that line in callback queue. Okay, so now how does it works? So as I was explaining, in stack memory, first it will execute console log. Okay, then it will go to bar. Okay, so bar is in turn calling some asynchronous function. Okay, so now event loop comes in. Okay, so what will happen? Our execution will not wait for the callback. So all the it will execute all the lines from the stack memory. Okay, first it will pop console log executed, bar executed. Okay, foo executed in bar. We are in turn calling bash. So that is our synchronous function. So it will not get called immediately. Okay. Once stack is empty, there is nothing to call from stack. Then JavaScript event loop will check into the callback queue. Okay. It will check into callback queue. It will give a it will execute it. It will check whether response is present or not, and it will execute it. Okay. So once callback queue is exhausted, it is checking in a loop manner. That is why okay. So but in Node.js, there is a slight difference in event loop. Okay. So if you go and check the Node.js documentation, there they have mentioned 6 phases. Okay. The documentation says that there are 6 phases in event loop. So first one is timer phase. Second one is pending callback. Third one is idle prepare. Fourth one is pause. Fifth one is check. Sixth one is closing callback. Okay. So let us go through the documentation definition for all these phases. Okay. So what documentation says that timer in timer phase, this phase executes callback scheduled by set timeout and set interval. Correct. What does that mean? That means uh, so whatever function callback function. So basically for set timeout and set interval, you pass 2 parameters, right? First is callback function that we are hoping to execute, and second parameter is the timer, right? In millisecond. So timer phase executes all those callback which are available for execution. What does that mean? That means that the second parameter, the timer for that set timeout has already elapsed, and now it is ready to execute. Okay. Pending callbacks. So pending callbacks executes input output callbacks. Okay, default to the next loop iteration. What does this mean? It means that asynchronous call is already called, right? It is already there, and now it is ready to send a success callback or error callback.
Okay.
Okay. So all those asynchronous calls which are waiting for execution, waiting to give some status, either success or error, those are taken care in pending callbacks. Idle prepare. This is currently a black box. Node.js internally use it. Okay. Poll. So in polling phase, so what does the definition says? Retrieve new input output events, execute input output related callbacks. Almost all the exceptions of close callbacks, the ones scheduled by timers, Node will block here when appropriate. Okay, we will come to this later. How Node will block here. Okay, check is only for set immediate callback. Okay, whenever set immediate callback function is invoked, that function is invoked in the check phase. And close callback phase is responsible for closing callbacks like socket close, my database closing connections, like that. Okay, so now we will be exploring these phases. Okay,
Okay.
How does event loop works? Okay, so if you remember, we were having only one callback queue in our JavaScript browser. Correct. So the only change here in Node.js is every phase has its own queue. Okay. So okay, so we'll come to these two things later. Okay. So basically, what will happen in uh, Node.js script? So basically, for every phase, there will be a separate queue. Okay. Then there are two priority queues. Okay, so these two priority queues are next tick queue. So whenever we write process.next tick callback, that will go inside this priority queue. And whenever we write promises, okay, all the promises, callback from all the promises goes inside microtask queue. Okay, so let us check how it works. Okay, so basically, let's say you have a node program, some business logic, okay, and number of lines of code. Again, the execution is same as the browser JavaScript. Okay, it will push all the synchronous methods to stack memory and all asynchronous methods to the queue. Okay, but here, since they have diversified it in 5 phases, it will push the methods accordingly. Okay, so let's say there are set timeout and set interval callback. So those will go into timer queue. Okay, IO callbacks, those will go into the pending callback queue. Then polling IO related all the callbacks, those will go into the poll queue. What is the difference between deferred IO callback and IO related callback?
Default is waiting for the
Correct. Yeah, correct. And IO callbacks, which are not yet called, those will go into poll queue. Okay. Check queue for set immediate and close queue for closing callback. Okay. So how it will work? So first entire stack memory will be exhausted. Always remember all the code which is present in stack memory will uh, get executed on higher precedence. Okay. Uh, Node.js event loop will shift the control to queues only after stack is exhausted. Okay. So first stack will be executed, console log, then bar, then foo. Then it will node event loop will check whether stack has anything, stack is exhausted. Then it will switch to the event loop queues. Okay. So now it will check. So what is the next line? So let's say next line is set timeout. Okay. So it will check whether set time has elapsed. No, it is not elapsed. Then it will go ahead. Okay. So it will check whether our current line has a deferred IO callback. If it is there, it will execute. Okay. Let's suppose it is there. Then it will execute, and then it will again check timer queue. Every queue it will check. Okay. So similarly, it will check for remaining ones. So that is why it is a queue. Sorry, it is a loop. Okay. Uh, so basically, let's try this to understand using examples. Okay. That will be more helpful, right? Okay. So we have first example. Okay. So what I want you guys to do is, uh, I want you guys to predict the output as well. Okay. So that you can build a good understanding for event loop. Okay. So here what we are doing, there are 3 functions. What they are doing, nothing but consoling. Okay. And we are calling them first, second, third, likewise. Okay. So what is first, second, third methods? They are synchronous, right? So what will be the output? Since these all 3 are synchronous, they will be pushed to the stack.
Yes.
And our precedence is always
Stack.
Yeah. So what will be the output?
First,
So let us do it node. Okay, so first, second, third, that is straightforward. Okay, so now let's check for a synchronous call for loop. Okay, again we have first, second, third. Only difference is we are calling second method in a for loop. Okay, so what will be the output?
first, second, 5 times, and then third.
Correct. Why? Because
Synchronous.
It is synchronous. Straightforward, right? Mallar, you are getting it right?
Yes, Manish. Yes.
You are with me, right?
Yes, yes.
Okay. Okay, let's check the next one. Yeah, so what we'll be doing now here, here again, I am calling second one. Okay. Sorry, calling third one from second. Okay, instead of, so there are now 4 functions, first, second, third, fourth, calling first one, then second one. Inside second, we are giving call to third and then fourth. Okay, so what do you think? What will be the output?
Does it give error?
Why?
Because second one will not get third.
Why?
It is written below the second function.
First, second, third, fourth.
Now?
Yeah.
Now okay, right?
Okay.
So now
Hosting.
First, second, third called by second, and then fourth.
correct, right? Why? Because it is synchronous. Okay, let us take example for callback as well. Okay, so what we are doing here, we are passing a function as a parameter to second. Okay, and what we are passing, so we are simply passing third function as a callback. Again, this callback is synchronous.
Yes.
So what will be the output?
First, second, third, fourth.
Second, third called by second, fourth.
Correct. First, second, third call by second, and fourth. Okay, now set timeout. So if you remember, what is set timeout? Set timeout is asynchronous, and which lies under which phase? Timer phase, right?
First.
So what will be the output?
First, third, and second.
Second.
Correct. Straightforward, right? Oh, sorry. Yeah, first, third, after all, second, the second one. So what happened here? If we go by our diagram, so first thing was first got pushed into first got pushed into the call stack. Okay, it identified that set timeout, which is a async function that got pushed into the timer phase. Okay, and third is a synchronous call, so it got pushed into the stack. So what happened then? It called third. It called first and third, and then it waited. It correct. So it waited until the 1000 is this time is elapsed. Once that is elapsed, this queue has dequeued the callback, the second one. Okay, until here with me.
Yes.
Okay, now let's check for 0 seconds. Okay, set timeouts. So here what difference I made? Only difference is now there is 0 seconds of delay, 0 milliseconds of delay. So what do you think? What should happen now at this point?
First, third.
First, second, third.
Why not second? Because anyways we are giving 0 delay, right?
No, but it goes in the timer and it will
Correct,
go the call stack to
Oh,
exhaust.
right.
Correct. First, second, third. So we have given 0 milliseconds of delay, but that does not matter. Why? Because anyways, Node.js will consider set timeout as asynchronous. So whether timeout value is 0 or other than 0, it is always going to be in the callback queue of timer phase. Okay.
Hello, Pranav.
Yes.
So let's see if there are more than 1,000 functions in call stack, and
Okay.
this second means that second has gone into that queue, right?
Hmm.
तर मग 0 मिलीसेकंड झाल्यानंतर ते रन होईल की मग पूर्ण स्टॅक एम्प्टी झाल्यावरतीच रन होईल?
It will run once stack is exhausted.
ओके. मग स्टॅक एक्झॉस्ट व्हायला जर समज 4-5 सेकंड लागून गेले तरी पण मग ते रन नाही होणार, राईट?
So
Hello?
basically, so I'm considering that. So yeah, correct. So in stack, we are having only synchronous methods, right? So let's say you have a big 1,000-line code. Okay. So it might happen that among 1,000 lines, only 40-50 lines are there which are doing synchronous job, right? And it, like, for synchronous job, Node is very, it is very fast. So it hardly take more than a second to execute all the synchronous tasks. Right.
Right.
Correct. But until and unless stack is exhausted, queues will not execute. Okay. So let's say for this stack to get exhaust, it is taking, let's say, 0.2 milliseconds. Okay. And then this 0 second set timeout needs to be executed. So this 0 does not mean that it will execute right away. Okay. So it will execute after that 0.2 seconds of delay. Why? Because this task needs to be exhausted.
Okay, Pranav.
Okay. Set timeout. Okay. So now here what we are doing, we have 3 functions. Okay. We are calling first one. We are calling second one in a set timeout. Okay. And then we are calling third one in while loop. Okay. And what is the condition? Condition is call the third one for 5 seconds. Okay. So this is I guess, bit tricky one, right? So what could be the output?
Third one is synchronous, I think.
First is synchronous.
Second is
Second
will go in the
timeout, and third is also synchronous.
Yes.
So what will be the output?
First.
Okay.
Then it will run for like 5 seconds.
Correct.
Third.
Correct.
In a block loop, and then
second. Correct. So see, but here we are giving a 0, right?
Yes.
So does it matter?
No, it doesn't matter.
Why? Because we have while loop in our stack memory. Yes. Right? Did you? Okay. So let's wait for 5 seconds. Then second, right? Set timeout. So let's check. Okay, let us reduce this to 2. Okay. Still no. 1 is fine then, I guess. Yeah, 500 should be enough then. I guess but this limitation is not there in terminal. I guess it is there in this terminal only. Okay, so Mallar.
Yes, Pranav.
So basically what it did, it first executed first. Okay.
Right.
Then it checked that say timeout is a synchronous call, asynchronous call. So it went into the timer phase, right?
Right.
Okay. So this second is inside the timer phase, and it will execute after this much time is elapsed. Okay. But since we know that unless and until stack is executed, this won't get executed, right? So what was the
Right.
next thing? Next thing was while third. Okay. So what we did here, was we blocked the event loop. How did we block? We blocked the event loop by calling synchronous function in a while loop for about a second. So what happened? It printed first. Why?
Then
Because first was it, it printed first. Then it checked that no, this is the synchronous one. It will take care of it later. Then it executed while. Okay. So what does while did? While executed for this much of time and until it gets terminated. So what does this did? This has blocked the execution of queue. That is blocked the execution of event loop. Once this execution is over, then only the set timeout callback was executed. So does it answer your question, Mallar, that if it is 0 and it is
yes,
taking 3-4 minutes, seconds of time, will it get executed? Right?
yes,
Correct, right? Now understood,
okay,
right?
yes.
So now let's check with set interval. Okay, so we have first, we have second. Okay, inside second, what we are doing, we are keeping count. That if count is greater than equal to 5, we are clearing interval. Okay, what does that mean? That simply means set interval will run the second function for 5 times. So what will be the output? First,
Third.
correct.
Then
Example, it seems easy, right? Event loop. First, third, why? Because they were synchronous, and then second 5 times. Okay. So now set interval with 0. Again, any will it make any difference?
No.
No, right? Why? Because set interval is correct. Okay. Now we have multiple timers. First, second, third.
Then first, second, and then third.
Correct. Why? Because it is getting registered in that manner.
Callback.
Like that, right? Okay, let us see if that is the case or not. First, second, and third. Okay. Okay. Now here we are making use of set immediate. So Mallar, what will be the output? Will like what will be the order of output?
I don't know much about set immediate.
Set immediate. What is
But-
set immediate?
But still, output will be first, third, and second.
Correct, right? Why? Because set immediate is a asynchronous callback function, right?
Right.
That is a timer function, right?
Yes.
Where? No. Yeah, correct. Set immediate comes under timer queue. Oh, sorry, check queue. Okay. So since that is a asynchronous thing, it will be pushed into the check queue, and our first and third will get executed. Only after that, set immediate will get executed.
Right.
Okay. Okay. So now here we have set timeout and set immediate, and then third. So
Third,
now,
first, and second.
Third, first,
okay, let us check. Well, right. Third, first, and second, right? Why? Because third is synchronous again. Okay, so what we did here, we called set timeout first, then set immediate. Okay. Now here we are calling set immediate first, then set timeout next, then third.
Third,
So
second,
third is
first.
same, but position of set immediate and timeout is swapped. So what will be the output?
Third,
second, first.
Let us check. Third, second, and first, right? So, so if I run this for multiple times, will it give same output?
Yes.
Same output, right? I doubt that because it shouldn't be same. Why? We'll check here. Okay. So here we have set immediate, first set immediate, second, third, fourth set immediate. Then we have timeout, first, second, third, fourth. And what we did? First immediate, set immediate, first timeout, second immediate, set timeout, third immediate, third timeout. So now what it should
first return all the timeouts.
Why?
Then set immediates.
Why?
Because in that loop,
Priority
first
of those queues.
timer queue, and then
Correct. So until unless timer queue is not exhausted, it will not go ahead. That is why. Correct. So let us check. I'm sorry. So what strange thing happened here?
the first timeout, it ran all the set immediate function.
And then
Other times.
so something is not correct, right? Now it is correct. Now it is correct. Again, something
Yes.
is not correct, right?
Right.
So why this behavior? So does that mean that event loop is failing?
No.
No, event loop is not failing. So let us find out reason for this. Okay. So on Node.js documentation, what they have mentioned is, yeah, okay. So they have mentioned is the order in which the two timers are executed is non-deterministic, as it is bound by performance of the process. Okay. Malhar, did you understood this statement?
No, I'm reading and trying to understand.
Okay. So basically what Node.js documentation is saying that performance of this process, set immediate and set timeout, is bound by the CPU performance.
Yes.
Okay, performance of the process. So let's say this set immediate has a callback, which is taking, which again in turn has a asynchronous callback. Or let's say this first immediate function, callback function is taking 0.2 seconds to execute, whereas timeout function is taking 0.1. So in that case, set timeout will execute first, followed by set immediate. Whereas here, if it is taking 0.1 and 0.2, then set immediate will, sorry, here, set immediate and set timeout. Then in that case, set immediate will execute first, then set timeout. So it is not deterministic. You cannot predict it. It is purely depend on the process. How much time does that process takes to execute set immediate or set timeout? Okay.
Okay.
So but isn't it weird that, because what we saw that there are separate callbacks, right? For this. Okay, let's read further in the documentation. Okay, so what does it says? It says the order in which the timer are executed are okay. This we already gone through. Yeah, correct. So, however, if you move the two calls within an input-output cycle, the immediate callback is always executed first. Okay. Yeah, correct. So, what is input-output within input-output cycle? That means, let's say you are reading some file, you are, basically it is inside a callback function. Okay, so here it is fs is an input output call, right? Cycle, right? So now inside the callback of fs read file, here there is set timeout and set immediate. In this case, the preference to set immediate is going to be always higher. Okay. The main advantage to using set immediate over set timeout is set immediate will always be executed before any timers if scheduled within a IO cycle. Okay, this point is important. So let's say you are working on some node project and you are observing that set immediate and set timeout are behaving in non-deterministic manner, then you should know. If you want them to follow their behavior, then they should go inside an input-output callback. Okay, so let us check that as well. Okay, so here we have a fs file read. Okay, inside that we are calling set immediate set timeout. Okay. Okay, so always set immediate will execute first, followed by timeout. Now, doesn't matter how many times I execute that. Okay, it is going to be in that way only. Set immediate followed by set timeout. Okay. So now let's explore the priority queue. I hope set immediate and the difference between set timeout and set immediate is clear now in both the cases.
Yes.
Okay, now let's explore the process.next tick, that is priority queue. Okay, as I told you earlier, yeah, one more thing which I skipped. So basically, whenever event loop checks whether timer, whether we have something in timer to execute, okay, then if not, then we go to next queue. So there is now one difference that it directly does not go to the next queue. It first checks after every queue is exhausted, every phase is completed, it will check the priority queue. Okay, so now new execution context is event loop will check if there is something in timer queue. If there, then it will execute. Then it will check if is there anything present in the priority queue. Okay, if yes, until and unless everything is executed in priority queue, control will not go back. Okay. So once a priority queue is empty, then it will check the next. Okay. Similar thing over here. If there are no pending callbacks, it will again check priority queue. Is there anything present in priority queue? Okay. So and similarly for every other phase. Okay. So what does that mean? That priority queue has higher precedence of execution. Correct. So let us understand it with examples. Okay. Okay. Process.next tick. So now we discussed that priority queue has highest precedence. Okay. If there is first line is process.next tick and next line is some asynchronous callback. Since these have higher precedence, see, it will check first priority queue and then go to phase, every phase. And after every phase, it will again check the priority queue. So what we have here, again, we have three methods, first, second, third. We are calling first, then we are calling process.next tick second, and then third. So what will be the output?
First, third, and then second.
Correct. Why?
It is asynchronous.
Correct. I agree that it has a higher precedence, but still it is asynchronous. Okay. So first stack will get exhausted and then only it will come down. Okay. First, third, and second. So now we will check. Here we have set timeout with 0. We have process.nextTick and we have third. Okay, so what will be the execution?
Third, second, first.
Third, second, first, right? Why?
Priority to have higher priority than
Correct.
other.
So once stack is exhausted, event loop will first check if there is anything present in priority queue. If no, then it will go to timer. Okay, set immediate process next tick and third. Again, same thing, right? In main loop. So third, second process dot next tick and then set immediate. Correct, right? Okay, so now let us check. This one is set immediate, set timeout, process tick fourth. Since set immediate and set timeout are in main loop, those are non-deterministic, but surely we can say that process dot tick next tick will execute first. Okay. So let us check. Okay. So what happened? Fourth, that was asynchronous, executed first, followed by process dot next tick, and second first are indeterministic. Correct. Now we will be calling same example inside input output cycle. Okay. So now what will be the output? Now things are pretty clear for us, right?
Yes.
So what will be the output?
Right. Fourth, third, first, second.
Correct. Anyways, process dot next tick, that is priority queue, has higher precedence. So once stack is empty, after fourth, third will get called. And since we are in input output cycle, we have rule that set immediate will get higher precedence. So first and second. Okay. Okay. Now let's check out next tick and microtask. Okay. So what is purpose of microtask queue? Microtask queue is responsible to execute all the promises. Okay, promise-based callbacks. Okay. So now let us check. So what if there is process.nextTick and immediately after process.nextTick, there is one promise as well. Right? Then what should happen? So what we have first set timeout, second set timeout, third set timeout. Okay. Then we have process.nextTick, three process.nextTick. Okay. Oh, but we don't have promise here. Okay. Anyways, we'll cover this as well. So set timeout and next. Okay. So again, this should be very straightforward now. So what we are doing, we are calling first timeout, second timeout, third timeout, and process.nextTick. Okay. But what we did it now here. So we are calling process. So here, since process.nextTick has higher precedence, it will get executed. Okay, that is fine. But as soon as second timeout will get executed, inside that we are again calling process.nextTick. So what will happen?
We will get first third process next tick will be executed.
Correct.
Then first set timeout, second timeout, then process first
Correct.
process next tick, second process next tick, and then
Correct. Why? Because this has higher precedence.
yes.
So that is why it will block the execution for third timeout. Sorry. Okay. So process.nextTick third got called, then set timeout 1. Okay. Set timeout 2 and set timeout 3. So where did it? So what did go wrong? What happened here?
It didn't stop.
Why?
Set timeout 3.
Why? What is the reason?
Because it is in time.
Does timer queue exhausted?
No.
That is why.
Okay.
Okay.
Yes.
So it observed that okay, I have observed two process.next tick. Those are got pushed into the next tick queue, but still timer queue is not exhausted. That is why second and third got executed, and then it went once this queue is exhausted, then it checked for the priority queue.
Okay.
Okay.
Yes.
It was tricky, right?
Yes.
But now it is simple, right? Malar,
Yes, Pranav.
understood this one, right?
Yes.
Not tricky anymore, right? This one. Okay. Now let's jump to promise, our micro task queue. Okay. Again, we have three methods, first, second, third. Okay. Third, we are calling synchronously. Then we are calling first and then second.
Yes.
Okay. So as soon as it observes promise, it will push it to micro task queue. So what will be the output? Third, then
First and then second.
correct. One and second, first and second. So how did this execution happen? So third got pushed into the stack. First then and second then got pushed into the micro task queue. Okay, so stack first stack executed. That is by third, followed by first and second. Okay. So next is promise versus process next tick. So what we are doing here, process.next tick and then promise. Okay, so it identified that first promise is pushed into micro task queue, then process.next tick as well pushed into the micro task queue. So now we are on same level. So which has more precedence? Any idea?
Process.
Any guess?
Process one. Process
Process
one.
dot next tick will have.
Let's find out. Okay. So first process.next tick got called, followed by promise. Okay. So what it will do, as soon as it comes here, it will check process.next tick has something, then it will check to microtask. That is why. Okay, so now process.next tick. Okay, so what we are doing here now, we are calling process.next tick inside promise. Okay. Little tricky one for more clarity. Let us do it like this. So what we have three methods. Okay. Three callback methods, three next tick methods. And what we are doing, line number one, we are resolving a promise. Okay, first resolving a promise, and then inside then block, we are resolving promise callback one, followed by promise callback two. Here, what we are doing, process dot next tick, promise callback two, promise callback three. Next tick callback two, sorry, next tick callback two, next tick callback three, and then promise callback three, and finally process dot next tick callback one. So according to you, what is happening here? How methods will get distributed in these two priority queues?
I think the same thing happened like in set timeout and
Process. Set time item process.
right. Line number 15 will be called first. Then
Hmm.
promise will be resolved. Promise
Hmm.
callback one.
All promises.
Callback two. Then for this, it will push in next tick, and it will go to the next. And then this also will be pushed in the next tick, and promise callback three will be resolved. And then it will go to the processes.
Processes.
Let's right. So what happened? Process dot next tick one. Let me expand this. Yeah. Process dot next tick one. Callback one. Why callback one? Promise, right? Callback one, callback two, callback three.
And then
next two, next three. So what happened here is, so it identified that here are promises, callback one, callback two. Okay, there are two more promises, total 5 promises. So what it did, as you know, interpreter works line by line, top to bottom. So it pushed all these promises, then functions over here in Microtask queue. Okay. So promise callback 1, 2, these two callback functions followed by 3 and process.nextStatic. Okay. So this promise is currently in pending state. It is yet to be resolved. Right? It will resolve later. So that is why first precedence go to process.nextStatic. It executed. Okay. Once that is executed, there is nothing in process.nextStatic queue. So it goes to promise callback queue. In promise callback queue, it executed promise callback 1, that is why callback 1, then callback 2, that is why callback 2. Then it found tick callback 2 and tick callback 3. That got pushed to process.nextStatic callback queue. But since our microtask queue is not yet exhausted, it kept running and it didn't interrupt with the process.nextStatic call. So then it executed promise callback 3 because that was the last thing which was there in our Microtask queue. And then once that is completed, it again check for the next tick queue. So ideally, it is like that. It got here. Then before going to timer queue, it first come to priority queue, and here it saw that okay, there are two things in priority queue: callback 2 and callback 3. Next tick 2 and next tick 3. Okay, Mallar, is it clear or it went?
No, it is clear.
It above your head.
No.
It is clear, right?
Right.
So now not so much tricky, right?
Right. Right.
Okay. Okay. So what
Hello,
we
Pranav.
learn? Yes.
What about those close callbacks?
Closing callbacks will go in the close callback phase, right? So let's say you have some socket connection, okay, and you are calling close socket or close MySQL function, something like that. Then those function will go in this close callback queue. If there are any, they will get executed.
And can you tell us about deferred and IO related callbacks? What are those?
Where is deferred? Oh yeah. Okay. So pending callback. Okay. So deferred callbacks means all those callbacks, all those synchronous callbacks which are ready to get served. Okay. You remember, right? Promise explanation.
Yes.
Correct. So what does promise do? Promise request some data and provides a callback and tells the service to return data, call the callback function whenever data is ready, right? So that is nothing but a deferred callback, deferred input output callback. So in pending callback queue, all input output. So your reading file is an input output callback, right? Reading stream, writing stream is an input output callback, right? Even
Right.
appending is an input output callback, file stream, file or stream or buffer. Even buffer is considered as an input output, right? Even if you give some input from a scanner, basically what scanner does, take input from console log, right? So callback to all those functions will go inside pending callback queue. Okay. So ideal again is internally used, so we don't know. So Node.js make use of it internally. Okay. In poll queue, all IO related callbacks go. Okay.
Okay.
In check, we just saw set immediate. The purpose of check queue is only to serve set immediate callbacks and then closing callbacks. Okay. Anything else?
Not yet.
Okay. This flow is, you understood the flow, right? First preference is
Yes,
stack.
right.
Then it will check priority queue. Then it will execute phase queues. After execution of every phase queue, it will again check for priority queue. Okay.
Yes,
So, yeah. So what did we learn from priority queue? We learned that set immediate do something on next tick, right? How? So if set immediate is there, then it will wait for stack to get executed. Okay. Uh, then then there are this much phases, right? It will wait for this much phases to get executed, and when it has it, it will do something immediately, right? So their name should be exchanged, but we can't do anything. Okay, so what are the main takeaways of today's discussion? So earlier Node.js event loop was complicated, but now it is not, right?
Yes.
Now it is
easy.
simplified, right? So Node.js event loop coordinates work between the call stack and the callback queues, right? Node.js event loop has multiple callback queues. We know how many? Six. And two priority queues. That means total 8. Okay. What we need to take care? We need to take care that one should not block the event loop. How did we block the event loop? If you remember, we placed while loop, right? And that kept printing for 5 seconds. Okay, so if your program is going into infinite loop, then it should come to you that I might be blocking the event loop. What is target? Mix and match usage of set time mode, set immediate process tick and promises. So, so how we can avoid this? So mix and match use, if we are doing a mix and match, then we should do it with care. Correct? Any questions for this session?
Like process.next tick will execute before every promise, and it gives
Correct.
higher precedence.
Yeah, so always.
For database initializing, we will use process.next tick.
No. So for database, so basically priority queues are there to to do some priority task. Why promise has a priority queue? Because we know that promise is going to be asynchronous, that is going to queue some either error or success callback after a few seconds of time has been elapsed. So that is why they decided to keep it into Microtask queue. That is a priority queue. Okay. So once that callback is available on higher precedence, it will take the callback. So let's say you have called an API. Okay. Then you continued the execution. Okay. But on later point of the time in your code, you will be needing that API response, right? Yes. So if we don't put promises in callback priority queue, then like it is of no use. Your program will get executed entirely, then output will be available. Then that is of no use, right? You want that output on line number 4 only after API is called.
I was like, what are the callback method we will use in process.nextTick?
Process.nextTick. So basically, okay, let's say you have some task to do, okay, and it is required. So let's say from backend, or let's say in your business logic, you have something to do. Some particular calculations are needed to do right away. Okay, you don't want to wait for an API response. You don't want to wait for anything else to happen. First thing should be this calculation should happen, and then remaining process should go.
Okay.
In that case, you can use process.nextTick. Generally, we avoid using that. Because why? Because it interrupts the flow, right? That is why. So process.nextTick can be used in very specific business requirements, like I explained earlier. Any other questions? No? So there is one more session that is prototypal inheritance. That is with L&D team. So I suggest you to go through that as well. That is not yet uploaded yet, I guess, but just take a follow-up. That is also important. So basically, how inheritance works in JavaScript. Okay. Yes, Malnar?
Let's see if our set timeout has it's 100 seconds of time.
Okay.
So first we have completed all synchronous tasks. Then we came to that set timeout, right?
Yes.
And
repeat again.
मराठीत बोलू.
Okay.
हा ऐक माझ्याकडे सिंक्रोनस टास्क आहे मी ते कम्प्लीट केले पहिले त्याच्यानंतर सेट टाइम मोठा माझ्या 100 सेकंड समज आणि त्याच्यानंतर माझ्याकडे एक process.next वाला आहे बट ते लगेच एक्झिक्यूट नाही होते ते नंतर येते माझ्याकडे समज असं काही तर मग ते 100 सेकंड वेट करेल त्यानंतर मग ते प्रॉमिस नाही तर काय ते रिझॉल्व करेल का
तुला आठवतंय का टायमर फेज जो आहे तो कशासाठी रिस्पॉन्सिबल आहे इट इज रिस्पॉन्सिबल फॉर कॉलबॅक ऑफ सेट टायमर सेट टाइमआउटचा टाइम इलॅप्स होईपर्यंत तो एक्झिक्यूट नाही होणार तो पुढे जाईल आणि पुढचं करेल वन्स टायमर इज इलॅप्स्ड मग टायमर क्यूचे कॉलबॅक फंक्शन्स एक्झिक्यूट होतील
हा राईट
करेक्ट
ओके करेक्ट
सर 100चं आहे आणि 100 मग ते 100 तर काय ते वेट थोडी करत बसणार आहे
हो शुअर समज
त्या क्यूचं नाव काय होतं की कॉलबॅक फ्रॉम टायमर फंक्शन्स
हा कॉलबॅक होते ते
इट डझंट मीन टायमर फंक्शन्स कॉलबॅक फ्रॉम टायमर फंक्शन्स
राईट
ओके any other questions
no
okay then thank you so much
thank you Pranav
if any doubts contact me directly okay
right yes
bye
bye